Okay, so we have the FC Twin. It's one of these dual Super Nintendo and Nintendo consoles, and if you have no power whatsoever, no lights on either side, no video or anything, we're going to try a fix that we found online. Hey there, okay, we have an FC Twin console. We have it apart. There's basically four screws for the case to take the two halves of the case apart, and then 6 screws, 2 on each of these boards. And pretty sure we have the common power supply issue with these where the voltage regulator is no longer functioning. So what we did is we removed the glue on the back and the little solder joint, and we removed this heat sink. There's a small screw and nut that holds the voltage regulator. This is a 7805, and it holds it to that heatsink. So then what we did was we just clipped the leads of the voltage regulator. This is a 5-volt voltage regulator, 7805, and it's shorted out. It doesn't do anything. So in these, the center pin in the input is negative, and the outer shell has this trace. It has a capacitor in parallel. It comes over to this pin, which goes into V-in of the voltage regulator. So we got signal to that, so this is good, but this whole thing is kind of extra. We don't really need this, to be honest, because this whole thing runs on 5 volts. So what we did is we clipped the pins, and we have now a ground pin in the middle, and we've used our multimeter to make sure it's still connected to ground, and we have V out of this voltage regulator, which is usually a clean 5 volts. And the way they designed this, it has about 10 volts RMS to this from an AC adapter. So this gets really hot. They have this huge heat sink in here, and it's causing all sorts of problems. A lot of people have complained they can't get any power, and there's a great forum online, I'll post a link to it, that said that one great modern way of hacking this console to work much nicer and more efficiently is to wire a direct 5-volt switch line to this, and that's your common you can get that conveniently through USB. So we can probably use one of these. I don't think it takes much current, but we can probably use one of these old Apple USB USB power supplies, and then we'll take a micro USB cord, chop it so that we have the 2 leads. We'll put some shrink wrap on it, and we'll see what we get when we put 5 volts directly onto this. And if it works, we can remove this old barrel connector, and we can remove that extra pin. But we're going to see what happens if we give this thing actually a clean 5 volts DC, where this voltage regulator should be doing it, and it doesn't seem to be. Okay, so after briefly connecting 5 volts to these 2 pins, the middle one and this lower one, which is V out from that old voltage regulator, we got a power light that blinked on. So before we go any further, we're going to hit the board with a little bit of light rubbing alcohol, some cotton. There was some dust and grime. It looked like maybe some liquid had gotten in, so we cleaned the whole board, get it all ready for the final phase of this. And it's really good to use Q-tips, or this can leave little fibers, so you go just use some tweezers and pluck them out. There's one right there, needle nose. Get all this stuff out of there. It might be glue. Okay, so once you get it pretty clean, that'll reduce the chances of any shorts in the future, which is good. So we melted the solder and used needle nose pliers to take out that other pin since it's unused. We're going to leave the capacitors because we also removed the barrel connector. We used needle nose pliers and removed it piece by piece since we don't have any solder wick handy. Can't get it all out at once, so we basically clipped the little connectors and took it out, and that will give us space to run our new power supply directly to those pins that were being fed by the voltage regulator, except we're going to run the cord through the power supply, the old barrel connector hole first. So we're going to take this and send it through here first. That way it'll just be a permanent cord, which is best we can do for now. All right, so we've used those old pins and we've soldered our new line that goes to a USB adapter right to there, and we're going to put the board back in the case and look for a way to do some stress relief on this, so this, if somebody pulls the cord, it doesn't yank it right off this. Maybe we can run it down and around these little mount posts or something underneath, so if it pulls, these little mount posts will take the stress instead of these very delicate little connections. So it looks like we have some spaces in here that we can make a loop around, so that if there's ever any sudden force, like somebody tripping over the cord, it'll pull on this and it might send the console flying, but there's no moving parts in this thing, but at least it won't rip our power supply off and have 5 volts bouncing around in there. So hopefully that, plus this one right here, I might do another loop around that one too, just in case, but we want to do something to take the strain off of that delicate connection. Did have to melt a small channel underneath where the barrel connector was, so that this board would sit flat. But now we have this board installed back with these 3 screws, and we have our new power supply going down and around the mounts a couple times. So now this is pretty solid. You can't pull this and yank it out completely. A better fix would be actually to mount a real USB connector in this barrel slot and then use this trace, but there's a capacitor on the line too, so I think that this is just the simplest fix, is to wire a line right to it. You use a nice big long USB cord, and usually this is sitting somewhere pretty permanently, so I don't think a hardwired cord to it is the worst thing, but you could definitely improve this by adding an actual USB jack on the back, so that you could remove all the cords like the factory original. But we got the main board back in, and we're gonna put a couple screws back into this and then see what we get for functionality. On this main board, the long screws go in this plastic tray. The connector, looks like we got some bent pins, so we'll fix that too. And then on the front, there's 2 shorter screws that go on the front of the console where the controller ports are. So we used a small tiny screwdriver and got the pins to look pretty nice. They don't have to be perfect, and hopefully it'll still work, but now we're going to try doing a little power test here and see what we get. We ended up moving the stress relief around this because the power cord fits in that channel really nicely, and that doesn't even, there's no screw that even goes in that mount. So that goes over there, and then that frees up the stress on this ribbon cable, because when we had it wrapped around there, the power cord was wrapping around the ribbon cable. So it looks like this little header right here, do a loop around that and push it into the crack there and wedge it in there. Then anything that pulls will pull on this rather than this connector. And we did have to melt a little bit more of a channel to get the board to sit flat, but we should still be able to use the back panel. So it looks like for power, we now get both 16 and 8-bit power, and reset button, we don't know if it works yet, but it looks like we got power to both modes. So we're going to put the case back together and go plug a game in. After putting it back together, doing a little wiggling of the game cartridge, looks like we have functionality. This power button is very cheap, and you have to really kind of push it down. You don't want to switch it around real fast, but to shut it off, you really have to push it all the way down. It doesn't really click. So I don't have any Nintendo games to test the NES side, but we can test the SNES side. Sounds good, looks good. This is what the new back looks like. This can sit right in that little track. The board is flat, so all the video connectors should go in. there we go. So to shut it off, sometimes it works, but sometimes it doesn't seem to work right. So there we go. Now we got a good connection. The game cartridges are very delicate to get working in it. To take them out, see there, give it a good slide down. To take them out, it's best to use two hands, but what you want to do is you want to wiggle it back and forth a little bit, wiggle it, rock it a little bit. Don't just grab it and pull it out, especially don't bend it forward and back at all. A little bit side to side, and then, and again, best thing you can do is just wiggle it side to side. These cartridges, this console is notorious for being difficult to take the games out, and you can see before we had some bent pins, and they're functioning now. But again, to put it in, you don't want to just smack it in. A little back and forth this way. And then, let's see. Yeah, there we go. So hopefully this helps. And this thing had 0 power, 0 life in it. And we did a power supply rebuild, and we cleaned all the boards and fixed the pins. And it looks like we have functionality for Super Nintendo. We'll find out eventually if the other side works. But buttons seem to be working. Okay, so for the record, this is a probably first generation, I think, FC Twin that has this holographic thing on the back. Yobo 2011 FC Twin system, NTSC, 10 volts, 600 milliamp. It says use FC Twin AC adapter. Not anymore. We're using good old USB, way lower power, way less heat, way less risk. And honestly, I'm not going to try it on this, but you probably could run this thing off a battery or off a computer or off like one of those power bricks because it's low power. So definitely, I think it's a first generation FC Twin. And I am not sure it really matters that they all seemed, all these consoles, these 8-bit, 16-bit consoles, all the chips in there use 5 volts, so it probably would work on a bunch of different ones. So, awesome. USB powered FC Twin. Shout out to the console hacking forum. Those guys are awesome. They're always modding all their systems, posting really helpful diagrams and schematics. I'll send links to them. All you guys are awesome for taking these things apart and finding all these nice little fixes. This is totally an upgrade for this power supply. We took out the big heat sink, the voltage regulator. It'll run way cooler and probably will draw way less power. So people on that forum put these things on batteries and they make them portable and stuff, but for now we're good just having it hooked up to a TV working again. So thank you guys again. Thank you everybody on the forums, and encourage everybody, if you're interested in console repair, to visit those forums because they're very, very helpful. I'll post links in the description. Thanks, bye.